In this video, we're going to talk about sum and difference identities. We're going to look at the formulas and then do some examples. Sometimes it's necessary to find exact trig values for angles on the unit circle, and other times it's necessary to find exact trig values for angles that are not on our unit circle. So we can use two angles U and V that are on our unit circle to find the sine of an angle that's not on our unit circle. Keep in mind there are 6 identities here. You have the plus and the minus of each of these sine, cosine, and tangent functions. So let's look at our first example. Here we have cosine of 195, which is clearly not on our unit circle. So we want to find two angle values that are on our unit circle and use these to calculate the cosine of 195 degrees. So the cosine of 195 degrees is equal to the cosine of 150 degrees plus 45 degrees. You can pick any two values here as long as you can find them on the unit circle and as long as they add or subtract to equal your original angle. Here I chose to use 150 and 45 degrees, but there are different options. So since I have cosine and I have an addition sign here, I know that I'm going to be working with u plus v. So in case we forgot, if we go back to our previous screen, cosine u plus v equals cosine u cosine v. And in case you haven't seen this notation before, here I have plus, which is on top. So I need to make sure that I take whatever sign is on top right here, which in this case is subtraction. So I'm going to have cosine u cosine v minus sine u sine v. Cosine u cosine v minus sine u sine v. So we're going to need to look on our unit circle and find the values for each one of these. Cosine u plus v. So my u is 150 degrees. So here I'm looking for what is the cosine of 150 degrees. If we look on our unit circle, we will find it's negative root 3 over 2. Staying with the cosine of u at 150 degrees, we can also go ahead and find the sine of u. So the sine of 150 degrees is 1/2. Now if we want to go to the cosine of v, which is 45 degrees, we know that's root 2 over 2. Sine of v, which is 45 degrees, that is also root 2 over 2. So now I can simplify. I have negative root 3 times negative root 2, root 6 over 4, minus root 2 over 4. And I can simplify that. Since my denominators are the same, I can combine my numerator and I'll get negative root 6 minus 2 over 4. Alright, this next example we have tangent of 15 degrees. So I want to rewrite 15 degrees using two angles from the unit circle. Let's say 60 minus 45 degrees. 60 minus 45 gives me that 15 degrees. Like I said before, you can also use two different angles here as long as they're on the unit circle. For example, I could have used 45 degrees minus 30 degrees. This is still going to give me 15 degrees. So whichever one you choose, you're still going to get the same answer. But I'm going to go with my original 60 degrees minus 45 degrees. So my sum and difference formula tells me tan u, we have minus in this case, minus v equals tan u minus tan v all over 1 plus tan u tan v. All right, so in this case, we're going to need to know what the tangent, here's u minus v, so I need to know what the tangent of 60 degrees and the tangent of 45 degrees is. I don't have these memorized, so I'm going to go ahead and up here, go ahead and figure those out. So I need to know the tangent of 45 degrees. Well, the tangent of 45 degrees is like saying the sine of 45 degrees over the cosine of 45 degrees, which is going to give me root 2 over 2 divided by root 2 over 2. And simplifying this, it's going to give me 1. So now I know that the tangent of 45 degrees is 1. I also need to know what is the tangent of 60 degrees. So using the same thought process here, I'm going to have the sine of 60 degrees, which is root 3 over 2, divided by the cosine of 60 degrees, which is 1/2. Simplifying this, I'm going to get root 3. All right, so using these two numbers, I'm going to find the tangent of 60 degrees minus the tangent of 45 degrees, which I just found above, 1 plus the tangent of 60 degrees times the tangent of 45 degrees. So plugging in the numbers up here, I'm going to get root 3 minus 1 over 1 plus root 3 times 1. All right, so clearly we have a radical in our denominator, so we're going to need to simplify this. Now I'm going to come down here and rewrite what I have. Root 3 minus 1, 1 plus root 3. So in order to simplify this, we're going to need to multiply both the top and bottom by 1 minus root 3. Okay, when I FOIL out the top, I'm going to get root 3 minus 3 minus 1 plus 3. When I FOIL out the bottom, I'm going to get 1 minus 3. Simplifying the top, I'm going to get 2 root 3 minus 4. And on the bottom, I get a minus 2. I can simplify this one step further by pulling out a minus 2 in the numerator, and I'm going to be left with a minus root 3 plus 2. My denominator, I have a negative 2, so now my negative 2's are going to cancel, and I'm going to be left with negative root 3 plus 2 as my simplified final answer. All right, this next example is an example where we can have radians instead of degrees, but we're going to approach it still the same way. I need to rewrite this in terms of 2 radian measures found on the unit circle. So here I have pi over 12. So I can have 3 pi over 12 minus 2 pi over 12. Here 3 pi minus 2 pi is still going to give me that pi over 12, so my math is correct. So now we can keep going. If I simplify this expression, that's going to leave me with sine of pi over 4 minus pi over 6. Okay, so we're working with sine u minus v, which is sine u cosine v minus cosine u sine v. Here's my u, here's my v. So again, we're going to look at the unit circle and we're going to fill in all 4 of these values. So here I need sine of u. U is pi over 4, so that's going to give me root 2 over 2. Cosine u, root 2 over 2 again. Here I have cosine v. cosine v, so I'm looking for pi over 6. So the cosine of pi over 6, root 3 over 2. And now I need the sine of pi over 6, which is 1/2. Multiplying these two together, I get root 6 over 4 minus root 2 over 4. I can combine my numerator since my denominator is the same. Root 6 minus root 2 all over 4, and that's my final answer. Okay, with this last example is a little different. Here we're given sine u equals 3/5, sine v equals 4/5, and they're both located in quadrant 1. And we want to find sine of u plus v and cosine of u minus v. Okay, so if we remember the formula one more time, we have sine u cosine v plus cosine u sine v. So again, these are the four values that we need to find. Here it already gave me sine u, so I can go ahead and say, well, sine u they gave me is 3 over 5. Sine v they also gave me 4 over 5. But now I need to figure out what is cosine v and what is cosine u. So I can draw my right triangle, call this angle u. Since I have sine is opposite over hypotenuse, we have 3 and 5, and I need to figure out what this angle is. I can use a squared plus b squared equals c squared. A we know is 3, b is what we're trying to find out, and our hypotenuse is 5. 9 plus b squared equals 25. B squared equals 16, and we get b equals 4. So now we know that this side is 4. So I'm looking for the cosine of u. Here's our angle u. Cosine is adjacent over hypotenuse. All right, now we need one more thing, cosine of v, so we can do the same thing. Draw our triangle, call this v. It says that the sine is 4/5, so we have opposite over hypotenuse, and we're looking for what the adjacent side is going to be. So if you look over here, this is a well-known triangle. It's our 3, 4, 5 triangle. So looking over here, I can tell that I'm going to end up with the same thing. And in this case, it's going to be a 3. So the cosine of v is adjacent, which is 3 over hypotenuse 5. All right, so now we can simplify, and we're going to get 9 over 25 plus 16 over 25, and that gives me 25 over 25, which is 1. Okay, and if you remember part B, I kind of wrote over top of it, so I'll just rewrite it down here. We're looking for cosine u minus v, and that formula was cosine u cosine v plus sine u sine v. The great thing is up here we already found all of our values. So cosine u right here we found to be 4/5. Then we have cosine v, which we found to be 3/5, plus sine u 3/5, and sine v 4/5. Okay, and simplifying this, we're going to get 24 over 25. And there you have it, all of the sum and difference identities.